So if we substitute in, now are you going to take the derivative now? What are you going to do then? Yeah, let's do some distributing and some cleaning up to get it as nice as we can here. What do you want to do first? Okay, so let's multiply 2 through and we get 400 minus 3y over 4 times y. Oops, over 6y, right? 400 minus 6y. Something like that. Now what do we want to do? Distribute the y, so we get 400y minus 6y squared over 4, right? Okay. Now, so what do we need to do now? Take the derivative, okay? How are you going to take the derivative here? Quotient rule. We could do the quotient rule. If we choose to, we can do one more step of cleaning up that might make it easier for us. Do you see that this is the same thing? This that I just wrote here is the same thing as that line up above it. Now we don't need the quotient rule. Now we've got 1/4 times this thing. So we should be able to take the derivative now by saying first times the derivative of the second, which is 400 minus 12y, plus what are we going to get when we do second times derivative of first? 0. Everybody see that? So suddenly we've got this nice derivative, 1/4 of 400 minus 12y equals 0. What are you going to do at this point in time? You could distribute the 1/4. Couldn't we divide both sides by 1/4 now also? If we divided both sides by 1/4, we just get 400 minus 12y equals 0. So 400 equals 12y. So y equals 33.33 repeating, something like that. So what does that mean? Yes, ma'am? I got the same answer, but I think it's completely different as in what?
Like, I don't know, for my thing I started out with, it was y times 100 minus 3 halves y, and then I took the derivative.
Okay.
Like that.
Look right here. If I say 400 divided by 4, I get 100, and 6 over 4 would be 3 halves. So I wind up with the same thing there. So yes, you could have done that. Yes, you just did simplification in different areas than we did, but still get the same thing. So now, what was the question that was asked? That's an important thing that students often miss here. What dimension should be used so that the enclosed area will be a maximum? Okay. So we know what y is now. We need to figure out what x is. How are we going to do that? Plug it back into something up here. Maybe this one that says 200 minus 3y over 4. So we would get that x equals 200 minus 3y over 4, which is 200 minus 100 over 4, which is 25. Now, the important thing that you need to be sure of, or one important thing you need to be sure of, is that it's clearly obvious which one is 25 and which one is 33. Because the x value, the one going long ways here, has to be 25. This one has to be 33 1/3 in order to maximize this, okay? So you've got to be sure that you do that. Do you need to do a sign line in order to be sure that this is a maximum? Technically you do, but let's think about something here. Look at this equation right here for the area. If we were to graph it, can anybody tell me what that graph would look like? A parabola? Why would it look like a parabola? It's got a y squared in it. So we know it's going to be a parabola. We know then the parabola is either going to be up or down, right? Is it up or down? How do you know it's down? It's got a negative sign. It's got a negative sign in front of the y squared. So we know it would be an open downward. So that means whatever that means that this point is a maximum. So officially, technically, will you have to do that? Yeah. Would I do it every time? No, I probably wouldn't. So 33 1/3 and 25 are the correct answers there. Okay? And all the problems that we deal with are going to be similar in nature to something like this. Now, I started to give you this one, but I changed my mind and I was nice to you, okay? A rectangular page is to contain 24 square inches of print. The margins at the top and the bottom of the page are to be 1.5 inches, and the margins on the left and right are to be 1 inch. What should the dimensions of the page be so that the least amount of paper is used? Okay. Read that for a second. Think about it. Most of the time we're going to wind up with two relationships here. Can anybody tell me a formula that we're going to have here? Area. Area of what? All right, but in this case the rectangle is what? The page or the print or what? Well, that's what I'm asking here. Okay, I think everybody can agree we got a rectangle here. We've got a rectangle, and so it's area is length times width. Okay, but what else can you tell me?
The length is 2 plus y.
All right.
Width is 3 plus x.
Okay, so the area, and when you say that, you're talking about the area of the page is, length is x plus 3. Jerry, explain to us where you got that from. Right, he's looking at the dimensions we're given here, 1.5 and 1.5 and x. All of that adds up to be x plus 3. And for the width, what are we looking for? Y plus 2. Is everybody comfortable with that? Because y is this distance in here from here to here, and we have to add the two sides onto it to get the entire width of it. So that's the area of the page, and we want to minimize that, right? It says so that the least amount of paper is used. So we need to find out if for what value makes this a minimum. Yes, sir.
Well, for the least amount of paper is used, what that means?
That means so the dimensions of this page. So we use the smallest amount of paper we have here, the whole overall page. See, we're going to put 24 square inches of print on here. But does this need to be 6 by 4, 6 this way and 4 that way, or does it need to be 8 up and down? Does that need to be 8 and this need to be 3? Does this need to be 12 and the width of it be 2? What dimensions do we need for the print in order to make the page have the minimum amount of paper there? That's what we're asked to do. We've got to have 24 square inches of print on here. So the writing on it has to take up 24 square inches of the page. That's right. No, so that the page itself can be the best size for us to have these margins around it and 24 square inches of print on there. We want to have this amount of margin around it. We want 1 inch margins on the side, 1.5 inch on the top and bottom. We want those margins and 24 inches of print. What size does a piece of paper need to be? That's what we're asking. Well, we've already done that here. So here's the thing that we want to minimize, right? What are the dimensions of the page so that the least amount of paper is used, so the area of the paper. So we want to minimize this. But what's the problem with taking the derivative of that right there? We've got two variables. So, yes, sir?
If we're worrying about the area with the print, like that has to be 24 square inches, why do we even have to worry about the margins until the very, very end? Why don't we just add in the margins at the end? Yeah, that's what I was saying. You see what I mean?
Okay, but look, but we're wanting the least amount of paper. We're wanting the smallest amount of paper. So you're saying, all right, so you're saying let's just worry about this here, minimizing it.
If you find the minimum of that, the outside's not going to change at all. So you could just find the minimum that would be 24 square inches and just add in the dimensions on this. We need two of those.
All right, so you're saying we just need to minimize x times y?
Because the outside won't change.
Okay.
Well, the 1 inch and the 1/2 inch, those are going to be constant.
How are we going to minimize x times y? We'll need to find the derivative and set it equal to 0, right? But we need, okay. What relationship is there between x and y right now? xy equals 24. Okay, all right, let's go back and do this just a arithmetic way. If we want 24 square inches of print, one obvious thing we could do is have 4 inches this way and 6 inches that way, right? Would you agree? That'll give us 24 square inches. So then, if we did that, then how wide would the page be? 6. So we'd have a page is 6 wide by 9 tall. That would be 54 inches of paper that we're using. Do y'all agree with that? Well, what if we did 6 this way and 4 that way? Does that change this 54? Because now how, if it's 6 and 4, how wide is the paper now? 8. And how tall is the paper now? 7. So that makes it 56. So 4 times 6 is better than 6 times 4. Agreed? We're going to use less paper? Well, what about 8 times 3? Or 3 times 8? Well, who says it has to be even? What if it's 7.5 by some unbelievably ugly number? So do you see that the margins do matter? Do y'all understand that? The margins do matter. We do need to take them into account as we're creating our equation here. So we do need to take these into account here. But this is an important piece of the puzzle right here. Does everybody see that that's a constraint? The 2 dimensions have to multiply to give us 24. So from this, we can simplify that and get, do y'all want to solve it for x equals or y equals? Okay, so x equals 24 over y, right? And now we can take this number and plug it right here. Would you agree with that? And now we have, bless you, now we have found that the area of the page is 24 over y plus 3 times y plus 2. Would you agree with that assessment? Bless you. Now, what do we need to do from here, you think? That's the area. We want to minimize it, so take the derivative. Do you want to multiply that out, or you just want to take the derivative as it is? I think I would just take the derivative as it is there. I think that's what I would do. So I'm going to give you a second and let you figure that out. Mr. Phillips' room. Yes, ma'am. It'll probably be about 50 minutes before he's back in, but I'll have him call you. Thank you. No problem. Bye-bye. Mr. Phillips needs to call his wife. Y'all help me remember that. All right, so what are we going to do now? We set it equal to 0. Where you want to go to? Okay, so I wasn't smart enough to do that, so let's see what I'm going to get over here. I'm going to get minus 24 over y plus negative 48 over y squared equals 0. Is that what I get when I multiply this fraction times this binomial here? If it does, it's really nice. Not easily, because here it's inside of a binomial there. But if we do that, that becomes really nice, because suddenly these two terms, not in there, these two terms right here disappear, don't they? So we get 3 minus 48 over y squared equals 0. So we get 3 equals 48 over y squared. 3y squared equals 48. So y squared is 16. So y is plus or minus 4. So, yes, ma'am?
Can we assume it's only going to be positive 4?
That's a good question. Can we just assume it's only going to be positive 4? Why is that? Yeah, we're talking about how wide something is or how long something is, right? Nothing is negative 4 long. So we, therefore, y equals 4. Therefore, x, which is 24 over y, equals 6. So the dimensions of the page need to be 4y times 6 long. Would you agree with that assessment?
Do we need to add margins?
Good question. What did it say? What should be the dimensions of the page? So the page is not 4 by 6, is it? The page is what? 6 by 9? Page dimensions are 6 by 9. Okay? Now, do we need to do a sign line to verify that? You can do it. I would jump to the conclusion that that's going to be a minimum, and we can really support the fact that that's a minimum because of that scratch work that I erased a while ago, can't we? Remember that was 6 by 9 was the 54 that we got before, and we did the other one and got 56. So this was a minimum there. So the minimum page is 6 by 9 there. Now, you have to be very careful with these types of problems. Specifically, this is the one example that I run into. If we change this to 24, to where the page is 24 wide, totally different story. Excuse me, where the page is 24 square inches, totally different problem. You need to work it a totally different way. We'll probably run into those later on down the road. But read your problems carefully as you look at them there. Any questions there? That's a tricky one in my opinion. Not hard, but tricky. All right? See what you can do with this problem. I'll give you a couple of minutes before I jump in there to help you. Talk with your friends. Talk with your enemies. See what they think. Think about what you want to maximize. Think about what's keeping you from making it just the biggest thing in the world. Because the biggest thing in the world would be the maximize. Jonah, what do we want to maximize here? Okay. Anyone else want to tell us what do we want to maximize here, you think? The what? The volume. We will produce a box with maximum volume. Well, how do we find the volume of this thing? The volume of a box, does everybody remember that the volume of a box is length times width times height? Okay, you do now. Volume of a box is length times width times height. What's special about our box? It's an open box. What else is special about it? The bottom is what? Square. So what does that mean? If the box is square? Length and width are the same. So we can say for the length, it can be X. The width can be X. Now the height can be anything because we don't know what it is yet. But it says it has a square base. The bottom of it has to be that. So we can simplify our volume to being X squared H. Now again, we want to maximize that so we could take the derivative, set it equals 0. The difficulty with that is we've got two variables over there that we don't like that. So we need to go back and we need to find a constraint. What does it say? The surface area is 100 square inches. Well, what does surface area mean? The sides. How many sides do we have to this box? 5. Why don't we have 6? It's an open box. So what the surface area then is the area of the 5 sides. What's special about the area of any of these sides here? I mean, we've got a box here. What's the area of the bottom of this box? Can anybody tell me? X squared, does everybody agree with that? Because it's that times that. What about each of the 4 faces of the box? X is how wide it is, H is how tall it is, and we've got 4 of them. So we know we've got plus 4XH. And what do we know is special about that? That's got to be equal to 108. All right? Now, so what are you going to do? We've got 2 equations. We know we're trying to find the derivative of the volume. That means we must be able to take this surface area and solve it for X or H1. What do you think we ought to solve it for? X or H? Y'all are right, one of it. Why do you think H? There's more X's. Let me ask you, how are you going to solve this equation, this S equation for X? You're going to have to factor it, aren't you? You're going to have to factor it because we got an X squared, because we're going to get 2 answers out of it. So it'll be much easier to take this equation and solve it for H. So I'm going to say 4XH equals 108 minus X squared. So H is 108 minus X squared over 4X. And now we should be able to take that over there and plug it in. Do you agree with that? So we get V equals X squared times 108 minus X squared over 4X. Now, you could go ahead and take the derivative. I will try to do a little bit more cleaning up here. I'm going to cancel that X with one of these up here. And I'll get 108X minus X cubed over 4. And I'm going to write it like this. The 1/4 out front because I don't like quotient rule. So I think I can stay at that. That's my volume. Now I should be able to take the derivative of that volume. See if you can take that derivative, set it equal to 0, and come up with an answer. Yeah. Yeah. Boy. Well, that worked out nice. When I worked out the answer there, I think it worked out nice. I think I got a nice number out of it. X times 108.
Do I do it wrong?
Yeah.
Do you not use the chain method? I did. No.
You don't have to. You see what I'm saying? Because when you cancel, you should, there you go. There you go.
Wait,
Yep, that's right.
that's right.
That's correct there.
The X.
But down here, you've got a little something different going on. Now, when I look at this, I just see a constant number 1/4 times this. So I'm going to say first times the derivative of this plus 0. Because I know when I take the derivative of 1/4, it's going to be 0. So all I've got is that to set equal to 0. And when you work through that, hopefully you get a nice number. What'd you get, Miss Gilstrap? Plus or minus 3? Nope, she's changing her mind. Back up on that. Stella, what do you get for an answer there?
I got X equals 6.
She got X equals 6. It's a nice answer. Oh, Kelsey and Claire got 6 too. All right. Because I think we can get there. Actually, we get plus and minus 6, but we can throw out the minus just like we could before. So that's what X is, and you're smart enough to go back and figure out what H is, I'm sure? Go plug it into whatever we had H equals something somewhere. 108 minus 36 over 24. What is that, 72? 3. 6 by 6 by 3. 6 by 6 by 3. Yes, ma'am? Did you get the 6? Well, let's see what you did. Oh. The derivative of 108x is not x. Nope. Right, not. Sorry. Now, do we need to worry about endpoints? Remember on Friday we talked about, aren't there physical constraints also to this? X has got to be bigger than something and got to be smaller than something, doesn't it? Could X be 0 here? Why not? Then we don't have a box, right? Okay. By the same token, could H be 100 and, I guess it could be 108. Could H, it could be, yeah, H could be anything. But there's constraints to it that, but does it make sense that the maximum volume is not going to be at 0 when X is 0? Because when X is 0, then you don't have anything there. Same thing for the others. So technically, if you wanted to be absolutely certain, you should do a sign line of this. But I'm confident that we don't have to. Ooh, does anybody, big question. Who remembers another way to determine that this is a max without doing a sign line? Second derivative. What's the second derivative of this thing? Can anybody tell me the second derivative of this by inspection? Just by looking at it? Yeah, you can. What's going to be the derivative of this thing here? Negative 6x. And when I put 6 into negative 6x, what's it going to be? Positive or negative? Negative. If it's negative, that means it is concave down. Therefore, it's a max. Okay? But there's no reason to do this. If you want to do the sign line, you can. If you want to do second derivative test. If you want to just go on faith that it's going to be right, hey, go on faith that it's going to be right. I'm okay with that too. All right, I'm boring you to death, so let's do a couple more problems here and let you move on. Closest to 0, 2. Closest to 0, 2. Wow. What does that mean? All right, look at what we're doing. We're measuring distances from points on here, and we want to know which point is closest to 0, 2. All right? So, I mean, we could just measure a blue million of them and hopefully, I mean, it's I don't think it can be anything down here. Would you all agree with that? Because it's getting further away. So it's kind of, I mean, gosh, we've just narrowed it down to just a few million there to pick from. So what does it mean to be closest? The shortest distance. Does distance bring any bells to anybody? FRQs, yeah. Does distance and position. But let's go back further than that, before this year.
The derivative of the function that is perpendicular to the point.
They're going to be perpendicular. Yes, you're right. You brought up something that I'd forgotten and not what I was looking for, but it's very, very true there. What does distance mean, anyone? How do we find distance? Y'all been doing this for a long time. Do y'all remember something called the distance formula? Y'all didn't sing the Addams Family? Yeah. Okay, you've heard of the Addams Family. You haven't heard of this. Okay. There's a song that goes with the Addams Family to sing that. I don't remember what it is, but there's something to it. Isn't the Addams Family? Da, 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 da. That's, okay. I can't remember. I know that's the tune. I don't remember how you say it. This is something called the distance formula. Okay, this is the distance between 2 points. Okay? So we're asked to find the closest point. If this is our distance, we want to maximize or minimize the distance? We want to minimize the distance. Now remember, x1 and x2 and y1 and y2 are points that we're finding here. So what are we going to use for those points? What are we going to use for one of those points? Can anybody tell me what one of those points is going to be? 0, 2. Which one do you want it to be? X1 and Y1 or X2 and Y2? All right, so this becomes X2 minus 0 squared plus Y2 minus 2 squared. Hey, we've gotten down to just 2 variables in there. If we could get down to 1, we'd be a happy people, wouldn't we? How could we do that? Oh, I bet you do. Hmm? That's exactly. What do you think? The thing at the top, elaborate there. Look, we know y equals 4 minus x squared, don't we? So what if we were to put that in down here? Does anybody see a way to simplify this puppy here? Just x squared. And in place of y, we can put 4 minus x squared minus 2 squared. I bet we can clean that up even more so, can't we? Yeah. 4 minus 2, I bet we can do that hard math in our heads. X squared plus 2 minus x squared squared. And we need to take the derivative, set it equal to 0. Now, the question is, do you want to take the derivative just like it is? Do you want to clean stuff up on the inside? I mean, do you want to square out that binomial and add the x squared so that you don't have, because right now I've got the chain rule. See, I got the chain rule, but then inside the chain rule, I've got another chain rule. So it's really not a lot of fun, okay? Let's do a little cleaning then, okay? I don't like cleaning. I cleaned this weekend, but let's do a little cleaning up here. 4 minus 4x squared plus x to the 4th. I think this 4 minus 4x squared plus x to the 4th is what you get when you clean up, when you square 2 minus x squared. Square the front, square the back, twice the product of the two. 2 times 2 is 4, negative 4x squared. Okay? Now I can combine these two together. So I'll have x squared. I won't have x squared. Come on, Ely. Get with the program. 4 minus 3x squared plus x to the 4th. And that's as clean as I can get. We just got to take the derivative now. Well, we have to use the chain rule. This is the same as 4 minus 3x squared plus x to the 4th raised to the 1/2 power. So how are we going to take the derivative of that? 1/2. All of that stuff to the negative 1/2 times, what's the derivative of that stuff inside there? Yes, that's an x to the 4th there. Thank you. Oh, it's not 4x. It's just x to the 4th. Yeah. Yes, 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 yes. And when we take the derivative of what was inside, we get negative 6x plus 4x cubed. Well, boy, that was fun. So now we've taken the derivative. Now what do we get to do? Set it equal to 0. Can we clean that up? Well, this is the numerator. This is the denominator. Agreed? It is disgusting. That is disgusting. But let's think for a second here. What is this square root here? But what is this square root describing? It's the what? It's the same as whatever this square root was here. What was this square root describing? The distance, right? The distance between 2 points. Where are the 2 points that we have? One of them's here, right here, and one of them is on this curve right in here. Is that distance ever going to be equal to 0? No. How do you know that? Because they never intersect. So that distance is never going to be 0. And furthermore, what if the distance were 0? Wouldn't that probably be when they were closest to one another? So this is never going to equal 0. So do we even need to worry with the bottom? No. It's never going to be 0. We know it's never going to be 0. So all we need to do is worry with the top. Negative 6x plus 4x cubed equals 0. Well, when is it going to be 0? Let's take out a 2x. That'll be negative 3 plus 2x squared equals 0, right? Can we do that? I guess we can. So we get x equals 0, and we get 2x squared equals to 3, or x squared equals to 3/2, or x is plus or minus the square root of 3/2. Agreed? So we have 3 critical points. Does that mean we have 3 minimums? Nope. That's a bummer. We need to do a sign line, don't we? Do we have to do a sign line here, people? What would happen if we just plugged it back into this original thing? Well, this original thing or this original thing? Okay? You've got a couple of options here. Listen, you're working real life here, agreed? We're working with a scenario. Does this have to have a closest point? I mean, there's got to be some place that is closer, doesn't it? I mean, there's got to be. There's got to be some place that is closer. So one thing you could do is evaluate this, which we cleaned up to this. You could evaluate this thing right here at those 3 points and see what you get. All right, let's do that. Distance is the square root of 4 minus 3x plus x to the 4. 4 minus 3x squared plus x to the 4th, right? What happens when I put 0 in there? Does everybody agree that I get the square root of 4, which is 2? Okay? Y'all comfortable with that? Well, let's put, what do you think about square root of 3 halves and negative square root of 3 halves? Tell me something. The square root will cancel out. Can you tell me any more than that, maybe? Do you think that when I put the square root of 3 halves, it'll be the same thing as the negative square root of 3 halves? Why do you think so? Because we're squaring it, right? When we square negative square root of 3 halves, it's going to be the same as the square root of 3 halves. So we can figure out both of those. The square root of 3 halves, that's going to be the same as the negative square root of 3 halves. All right, I'm just going to put 3 halves in here, okay? 4 minus 3 times 3 halves. Would you agree with that? Plus 9/4. Would y'all agree with that? That if I square this, I get 3 halves, right? If I square something that's being squared, it gets to the 4th, to the x to the 4th, right? So if I square 3 halves, I get to 9/4. Squaring 3 gives me 9. Squaring 2 gives me 4. So I get the square root of 4 minus 9/2 plus 9/4. And then I could get this 8, let's go to fourths, right? 16/4 minus 18/4 plus 9/4. 16 minus 8 is negative 2 plus 9 is 7. So I get the square root of 7/4. That blows your mind there? That's impossible to do at this time of day, isn't it? It's less than 2. So the closest points are plus and minus square root of 3/2. Okay. Hey, you're in luck. There's only one on that, one on the WebAssign like that, right? Yeah. There's only one. There's only one like that. Only one like that. That's right. That's right. The question is, did we answer the question? Which points are closest? What do we know? We know X. We know when X is that number. How do we find Y? 4 minus 3 halves. 2.5. Yes, sir. Yes, sir. Okay. You need some time to suffer on your own. Okay. So what I'm going to suggest is we'll do that tomorrow. Sorry. We'll do that on Wednesday. I'm going to suggest you jump over here to where it says your turn. And I'm going to ask you to do just this problem right here. Not a lot of words, so that makes you feel better. This problem. Oh, let's don't do that. contain 36 square inches of print. Yeah, this problem. 3 problems by the next time we meet, okay? Not 10 minutes. Okay? 3 problems by the next time we meet. Now, you have a WebAssign over this due Wednesday. Video problem due Thursday. Yes. The video problem is also over optimization. And you've got 3 FRQs on Friday. All right? Do y'all know which 3 problems you're doing? Find the length and width of a rectangle. Product is 147. 36 square inches of print. Okay? Now you have something to do.